Welcome everyone to Unscripted Coding. Today our topic is optimization. And in front of me is a piece of accounting homework, not my own, but the idea here is a very classic business accounting type problem. You have to assign a number of sales representatives and they cost a certain amount of money. And you got to allocate them across a number of districts, and they all have their sort of constraints. Very classic optimization. How do you stretch your dollar, make sure that everything is satisfied without paying more than you have? If you think about it, you can have 1 million representatives in each district, and that would work. But of course, that would cost way too much money, and you want to solve this properly. Now, the classic way that I've been taught in my accounting classes was using the Excel solver add-in. And it's funny because I'm looking at tutorials point. The last time I touched one of these is maybe 7-8 years ago, and it looks exactly the same. You chart it out in Excel. So what is the cost? How do the constraints work? What is the revenue you want to hit or the number of calls you want to answer? And you plug it all into these parameters, and Excel solves it. You choose a regression method, and it spits out an answer. It's handy, it works, but I think we're going to look at this less like a business student of how do I plug this into Excel, and more like a computer scientist, a programmer. You got to think about the problem. How does it work? Where are the changes? That way you can understand it and potentially anticipate what other things occur. Now, number one, there are tools in Python to actually solve optimization problems as well. So if I Google it, I haven't used these before, but you can use Pulp apparently to do this, and you have options of regression. I know there should be many other optimizers as well. And similar working, it spits out an answer. I don't find that helpful. What I think is going to be helpful is we're going to build out this model in Python to try and spit out an answer. And what I've noticed, at least just mulling this over quickly before this video, is that it lends itself to Monte Carlo very easily. And what I mean by Monte Carlo is we're going to run tests over and over. So the key here is right here. A fractional number of representatives in a district is not possible. That means you cannot solve this by saying I will hire 1.31 individuals. No, it has to be 1 or 2 representatives. The other piece I've noticed is right here. I think I'm going to have to read the text in a second, but each sales rep can work 160 hours. And for the most part, if they go to their own district, it takes 1 hour to answer each call. There's 60, 90, 120, and 70 calls. What that tells me is that one solution, maybe not the optimal one, is 1 representative in each district. And why this is important is because I think there are very few variations that are going to work. You might have 1, you might have 2, you might have 3 representatives in a district, but I don't see much more of that. And so you have a very finite set of variations to solve this particular problem. You might have 1, 2, 1, 0 or 2, 1, 1, 0, something like that, but there just aren't very many variations that you'd stress out your computer, all of that. It's a very simple equation, and you might run, let's be generous and say 100,000 simulations. It just isn't going to take very much, and you don't need to run through regression to solve this. Okay, let's actually understand this problem deeper. I'm going to read it from top to bottom, but then I'm going to highlight what I noticed immediately afterward. A large drug company must determine how many sales representatives to assign to each of 4 sales districts. The cost of having n greater than 0 representatives in a district is $48,000 plus $80,000 per year. and you only pay the $48,000 fixed cost if there is at least one sales representative at that district. If a sales rep is based in a given district, the time it takes to complete a call on a doctor, the sales rep travels to a doctor's office, in each of the actual sales call district is given in the following table where the time are in hours. This table right here. For example, it takes a sales representative in base district 2 4 hours to complete a call on a doctor in district 1. It takes a sales representative in base district 4 2 hours to complete a call on a doctor in district 3. Each sales rep can work up to 160 hours per month. Each month, a certain number of calls, given in the following table, must be made in each actual sales call district, i.e., this is the total number of calls to be completed by all of the sales reps. This chart right here. A fractional number of representatives in a district is not permissible. Determine how many representatives should be assigned to each district. I don't think there's a lot surprising here, but a couple things to notice. First thing is, I think there's a typo here. And why did it get so thick? There we go. Nope, too thin. And the Goldilocks size, perfect. N greater than 0. It suggests to me, at least this little bit right here, means that you have to have greater than 0 representatives, 1 or more. But I think that has to be a typo because you only pay the fixed cost if there is at least one sales representative at that district, meaning that they have contemplated situations where there are 0 in certain districts and a number of individuals in other districts. So I'm just going to ignore that for now. I don't think that applies. The other thing I noticed is this part right here. They gave you two examples from a representative from District 2 going to District 1 takes 4 hours. Okay, so they are 4 times less efficient than just having a base representative in that base district. They are 4 times less productive. And this chart is mirrored across the board, meaning that if you travel from District 2 to 1, it takes the same time and the same inefficiencies exist if you go from 1 to 2. This is true across the board, so 5 and 5, 3 and 3, all symmetrical down this line. What I wanted to work out right away is the distance. And if you take a look at District 1 right here, it is closest to District 2, then 3, then 4. It's a very linear relationship. So one of my fears originally is that 1 might be close to 4, might be, 3 might be situated over here where it's close to 2, but it's actually closer to 1 than it is 4, blah, blah, blah. We don't have to worry about that because it is a very linear relationship. If you take a look at District 2 next, it's closest to 3 and 1, furthest from 4, but it's actually slightly closer to 3 than it is to 1. And all of this is true. 4 is furthest away from 1, then 2, then 3. So it's almost like a line. Yes, they're not perfectly exactly split up the same way, but it is a linear distance. The last thing in my mind that I'm running through is that this fixed cost, and oh no, we've swapped again. This fixed cost is $48,000. And to me, this is a really interesting piece because I don't even know if we need to go to the Monte Carlo to solve this. Because a $48,000 fixed cost is less than the cost of one individual, one sales rep, okay? Think about what that means. You have to be fairly productive to make it fairly efficient to make it worthwhile to replace it. What I'm saying is the fixed cost isn't so huge that it's like 3 or 4 or 5 different reps. it is less than 1. You have to be, when you look at any of these numbers, 5, these guys are 5 times less efficient than having a sales rep in that place. And the fixed cost is less than the cost of one representative. So to me, it seems to me right off the bat, it makes very little sense to actually hire 2 people, say in base district 2, so that it can service district 2. The fixed cost is just too low to make that seem worthwhile. And so the only one where that seems to make sense potentially is the relationship between 3 and 4, where the number potentially is low enough at just 2 times the efficiency, it might be worthwhile. Now, as I'm looking at this, I think 1, 1, 1, 1 is a decent solution. You are not breaking bank. You are not highly inefficient by going 1, 1, 1, 1. But what I'm looking at this is, let's start from 1, 1, 1, 1 and see how we can improve it. And so we have 160 hours per month. If we have 1, we have 100 hours left over. In District 2, we have 70 hours left over. We have 40 hours left over. And we have 90 hours left over. What I think you want to do is figure out this particular chart. And I hope we can do this in fairly quick order. Okay, let's choose a different color here. We're not going to service these ones. But over here, 100, and I'm matching these numbers right here. Okay. 100 divided by 4 is 25, then 20, then let's say roughly 14. I'm just rounding here. 70 we have divided by 4 is about 18. Then divided by 3 is 23. Divided by 6 is roughly 12. 40 divided by 5 is 8. Divided by 3 is about 13. And divided by 2 is 20. 90 divided by 7, about 13. 15. And 45. Okay? That is a real interesting chart right here. Because what I think makes the most sense is to try and turn one of these districts into 2. And it may not even make a difference. If we want to use the spillover from the other 3 districts, we are at 20, 24, 27, 37. Brings it reasonably close to 1, but 1 is far away from everyone else. District 2, you have 40, 53. A bit further from this one, 90. And over here we have 88. And finally, over here, we have 46. Yeah, I don't think it makes a difference. What I think you can do, so for example, if I don't want to pay for District 4, the spillover from these other districts is going to be 46. So what we only have to deal with is, in reality, 24 over here, or 32, or 37, or 23 for each of these, just spillovers from the 1111 in the other districts. And what that means is if I hire 2 in District 3, there's going to be more than enough hours to satisfy this one. Okay? So that is, I think, right off the bat, the minimum, that is the optimal strategy. You have 1, 1, 2, 0. And you haven't done all the math, but just understanding the problem and getting a sense of what's happening here, I think 1120 is a solution. And I think what you can actually do is go 1210, which of course is the same cost, the same minimal solution. And this will solve elsewhere as well, because you can move to District 3, 160 hours divided by 3, you more than satisfy the 32 right here. And so there's more than one solution here, but essentially it's going to be 1120 in some combination. Okay, I have been talking for quite a while. This is my logic and how I think the solution is going to be. But what I'm going to do is not talk and build this out in Code Sculptor. See how we can build a Monte Carlo solution. And confirm whether I'm right or not. I could be way off base here. That will be the fun of it. And we are back. So, I have this up on Code Sculptor. I'm gonna save the URL into the description here. But, first of all, I think we had it dead on. If you think about the problem and if you break it down and think about it logically, you only had two real solutions. And you know what? I should probably just run the test with larger numbers as well, just to make sure that I cover all my bases. Oh, nope. Still two answers. So if you take a look, and I apologize, a dictionary shuffles all the time, but District 1, 1. District 2, 1. District 3, 0. And District 4, 2. And in this case, we just swapped the District 3 and 4 instead. So 1 and 2, both 1 representative. 4 and 3 will either be 0 or 2 and vice versa. And you will have the lowest cost of $464,000. How we did this is actually took longer than I thought. I think just a little under half an hour to build this out because I struggled with this little bit in the constraint. I didn't realize it was tougher than I thought. So, maybe Excel is the way to go. But let's walk through what I did. First of all, the entire thing was structured around this num reps. And this was a dictionary that basically looks like this. District 1 has, say 1 person, District 2, 1 person, District 3. It's just a dictionary so that you can search by district how many numbers of representatives there are. And I pass it to two different functions here. First is total cost. This one is very easy. For each district, I'm going to go 48,000 if there's more than one individual, one or more individuals, and add 80,000 times the number of representatives. So I spit out what the total cost is given a structure, say, like this one. Okay? Then run through the constraint process. we can have 0.000 rep, which of course would have the lowest cost, but the constraint is that we have to satisfy the required number of calls. In this case, it's hard coded at 60, 90, 120, and 70 for the various districts. And what I've done is you build it out based on the number of reps. In District 1, let's say there's 1 representatives, there's 160 hours, because 1 times 160, and we spit out all the hours. What I then do is create this subtract diff function to start fixing things out. And this was where I had to just stop for a moment and think about how they could look. But basically, I'm going down the list and saying, take out the number of the requirements, so subtract it all the way down to, say, 0, and remove the required hours. Now, the only way you can do this, I'm going to pull up the question again here, is you need to do it from the lowest value, the best value down to the lowest value. Sorry. You have to go from best value to the lowest value. And what I mean by that is certainly I can start subtracting rep 1's hours for District 4, but it's so inefficient at 1 to 7 that should be the last thing you do. If you have spare time in rep base District 1, then you have spare time number 7, then you get to District 4. But obviously you want to apply it to where their time is most efficiently spent. So the 1, 1, 1, 1, that is where your first step is. You want to use the hours so that you get the maximum value. Then the next set of best value is 2, then 3, then 4, then 5, then 6. Then 7. Because if you get 1 to 1 for your hours, that's great value. If you get 1 to 2, that's the efficiency. You don't want to do that unless you have to. And then a third of the efficiency, a fourth, a fifth, a sixth, a seventh. You don't want to get there until it's absolutely necessary. And so that's the logic that goes down this section. We are going through the value 1. This is the last digit. Then the 2s, then the 3s, then the 4s, then the 5s, then the 6th, then the 7th. But basically, this subtract diff file takes the hours and requirements and updates it accordingly. We have the district source, the destination, and the value, the cost. And so it looks very painful, but all it's saying is if you have enough hours, then just subtract it down to 0. If you don't have enough hours, then take as much as you can to get it to 0. And this if is to avoid the whole negative numbers. So I want to chain it to 0 because we don't want, negative 50 hours. It doesn't work that way. It looks a lot more painful than it really is, but it's a very basic kind of idea. You just got to scale it, divide it by the right amount of inefficiency, and you spit out the right numbers. And you just go down the list. And in the very end, what I do is I go through the requirements and make sure that they're all at 0. So for each district, make sure the requirement is equal to 0. If it's not, then I'm going to return false, meaning the constraint isn't satisfied. You haven't fulfilled all the number of calls. So I keep going back to, yes, 0, 0, 0 is the cheapest, but you haven't done any of the work. So the constraint would return a false. You haven't satisfied it. Finally, the last bit is just a pass. Now, I threw a number. You can add a bunch of zeros to this. It doesn't matter. But I knew right off the bat there was an option of, I think, 528,000 if that was 1111. So naturally, I didn't need this number to be super large. 1 million is more than enough. But I'm going to test every combination of number of reps up to 7. So I will test from 0000 all the way to 777, including all of the variations of 0123, 0127, blah, 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 blah. All of them, just keeping track of what the lowest cost is. And I print out what what the lowest cost is. And in this case, you can see it starts high and it starts trickling down. I just want to see what all the options are. But we get to the two answers we expected. The lowest way we can solve this is $464,000. And it is when we have one representative in District 1, one representative in District 2, and either two representatives in District 3 and 0 and 4, or 0 reps in District 3 and 2 representatives in 0-4 in District 4. So, this was a lot of fun because I think it's so important to actually think through the problem. Then you shouldn't have needed to plug this into Excel to figure all of this out. You want to understand what it is you're doing, and then you can create a model. So, I hope that helps because we are so often thinking about problems that show up in, say, LeetCode that have a very neat way of doing it programmatically that we don't often think about the real problems. And business students just keep running through Excel and they're not thinking about this in other ways as well. So I hope you had fun with this exercise. This brought back memories. I don't know how many of these types of problems I solved when I was a bit younger and doing my accounting degree. So, let me know if that was interesting. I'm happy to tackle more business school commerce related problems from a programmer's type of perspective. It's very nice that these numbers worked out so easily because next time maybe I can try and see what this pulp thing is, or we can show off Excel Solver for people who are not familiar with it. Anyways, thanks for watching. I hope you enjoyed the video. If you did, leave me a comment, thumbs up, subscribe. If not, let me know anyways. I'd love to keep creating content that you guys enjoy. Thanks for watching. See you guys next week.